Okay, today we're going to look at the Math 30-1, Topic 5.1, the graphs of the sine and cosine functions. This starts on page 222 of your textbook. Here we're going to look at sine and cosine functions, and we're going to say that they're what we call periodic functions because they repeat. Y equals the sine of x is called a sinusoidal curve. In its basic form, it's y is equal to the sine of theta. Let's look at some different values and graph it over one full rotation of the circle. Now we know some points. We know where the x and y intercepts are, and we know root 2 over 2, root 2 over 2, and that's enough to get us started. We can put down our theta and sine theta. When our angle is 0, sine theta is 0. When it's pi over 4, sine is root 2 over 2. As we move around the circle, when we get to 90 degrees, or pi over 2, the sine of theta is equal to 1. And keep going around the circle at 3/4, 3 pi over 4. It's going to also be root 2 over 2. And when we get to pi, the sine of theta is equal to 0 again. And as you go around the circle on the negative side, there's going to be our values. Now we can plot these. Our x values are going to go from 0 to 2 pi. Our y values are going to go from 0 to -1 to +1. If we graph these, you'll see that it forms a wave, or a curve. This is a sinusoidal curve. After 2 pi, it's going to start up as we go around the circle again. That's why we call it a periodic function. That's what it's going to look like. One period is one wave. Where it starts to repeat is in the next period. So as you can see, where the wave starts and where it ends is one period. This is the graph of y equals the sine of x. Now we're going to compare it to the graph of y equals cosine x. With y equals cosine x, you're going to plot those same points. The cosine of 0 is 1, the x values. Pi over 4 is again root 2 over 2. At pi over 2, the cosine is 0. And you can go around the circle and plot the points, and this is what the wave is going to look like. Right at x is 0, it starts at 1, goes down into -1, and then back up to +1. So it's almost an inverse of the sine function. Something called the amplitude. When we look at the graph, if it goes from -1 to +1, the amplitude is said to be 1. That's why it's y is equal to 1 times the sine of x, or y is equal to 1 times the cosine of x. If I drew the graph of y equals 2, or if it had an amplitude of 2, it would go up to +2 and down to -2. It would have twice the amplitude. Amplitude is referred to as the vertical stretch. Y equals a sine x. If you looked at a couple of graphs in your calculator, like y is equal to 2 times the sine of x, or even y is equal to 0.5 times the sine of x, you'll see how that value for a affects how high it reaches, the vertical stretch of the graph. And again, on our first graph, our amplitude has 1. So if we looked at y is equal to a times the sine of b times x, the a value is our amplitude. That's our vertical stretch. B affects the period, affects how often it's going to repeat. By definition, the period is 2 pi divided by the b value. And it's 2 pi divided by the absolute value of b. We just take the positive of it. So let's look again. Y equals the sine of x. It has a period of 2 pi. That means every 2 pi units, there's going to be one period. It's going to repeat. It's going to start repeating right after that. The amplitude is how high it reaches. Let's look at another one. Let's look at a graph of y is equal to 3 times the cosine of 4x. Now, this time, if you look at it, the amplitude, or the vertical stretch, is going to be 3. That means that when we draw it, the vertical stretch, every y-coordinate is going to be multiplied by 3. When it's the cosine of 4x, that tells me that every x-coordinate is going to be divided by 4, just like we learned previously on translations. So if you looked at these values, if it was 0, 1, this time it's going to be at 0, 3. The y-coordinate times 3, the x-coordinate gets divided by 4. So notice when we plot these points out that 0, 1 goes to 0, 3. Pi over 2 goes to pi over 8 and 0. So here's the graph of what it's going to look like if we plot these points on our number line. And you should be able to plot these both on your calculator and on a line. This is a graph showing 2 cycles. If I do another one where y is equal to 3 times the sine of 4x showing 2 cycles, again, we're going to plot those points and you're going to see what 2 cycles looks like, and there we go. There's our graphs. Your assignment then is to do page 233, numbers 1 to 15.